Hi everybody. I just wanted to give you a chance to get to see again how the 9.1 problems work, and hopefully this can help in your homework. I picked a problem to work, so we're going to do number 2. We did number 1 in class, so let's look at number 2 here. I've done a little kind of lead-in work on this, so I'll just read it. It says below are electrolyte pH levels, which are the x coordinates, and electric currents, y coordinates, in amps, from 10 acid-based batteries. The batteries only differ based on the electrolyte, so that's just the liquid that's put in the battery. And so it says give the means and the sample standard deviations for x and y below, and the sample correlation coefficient R. This should be computed using technology such as a scientific calculator. So I've got a calculator over here that it's a TI-30XS multiview, which is basically the same as the TI-36 Pro. So, and I've already keyed the numbers in, so you'll see how similar this is. I'll clear my screen, press the data button here, and I've already keyed all the values in. So if I press clear again, I would do second data, and I'm doing 2 variable stats on this, so I'll select that. And this is kind of the same as the TI-36, basically the same idea. And now I get all my statistics just like that calculator. So I'm going to just go through this and put the numbers down. Actually, I'm going to put on my iPad first because we'll need to refer to them. So the X bar is 4.42, but it wants one place. So I'm going to just do 4.4 on X bar. Okay, standard deviation on X 1.8587. It wants 3 places. So I'm going to go 1.859 for the standard deviation of X. Okay, for Y bar, it goes back to one place. Let me just go down on the emulator here. So Y bar, again, one place. So we're going to write 4.7. Little trouble here. 4.7. Standard deviation of Y. Right here. So it's this 1.151. It's going to want 3 places. Okay, and so we got all that, and then we're going to need our R value, and so let me just, that's way down the list here. Okay, so the R is the negative 0.954. I think I'll do negative 0.954. Okay, and it's asking for 3 significant figures there. Okay, so those are the big numbers. I think I can clear the screen on the calculator. We will need the calculator later, but not for that. Okay, so the X bar was 4.4. The Y bar was 4.7. Standard deviation of X 1.859. Standard deviation of Y 1.151. And then the R value is negative, let's see, what was it? 0.954. Like that. All right, so then let's just check them. Let's see if I can scroll in a little bit, just a little zoomier. So check that. Okay, so everything checks out. That's great. And now we have to do the slope and the y-intercept. So the slope has this formula, and the y-intercept has this formula. I've got all the numbers, so I can do this computation. I'll just go over to the my iPad here. So for slope, we're going to do R, which is negative 0.954 times the standard deviation of Y, which is 1.151. Over standard deviation of X, 1.859. There. So go ahead and do that on the calculator now. So negative, let's see, negative 0.954 times 1.151 divided by 1.859. Okay, I hope I got all that right. I'm going to get negative 0.591 I'll go with, and it wants 3 places. There. I'll check that. It's wrong. So it should be 591. Classic me mistake. Okay, and then back to the iPad here. So for the y-intercept, this is equal to y bar. Y bar is 4.7. Minus the slope, which is this is gonna be a double negative. So this slope I didn't write it down, but it was negative 0.591, negative 0.591 here. So we've got a double negative, negative 0.591, and then it's times x bar, which is 4.4. Right? Yeah, 4.4. Okay. Now, double negative, when you subtract a negative, that's the same as adding. So, and it's kind of a pain to input a double negative like we have right here on a calculator. So you can, but you should use parentheses the way I wrote them. But it's easier just to remember when you subtract a negative, that's the same as adding. So here I would just do to the calculator. Let's see if I can find that. 4.7 plus, can't see the whole thing, it's 0.591. Times 4.4. And they only want one place after the decimal here. So we're just going to put in 7.3 for the y-intercept. So I'll also check that. Looks good. And next, the line of best fit. So that's, I can do this over here now. So in general, it's just the y hat is equal to the y-intercept plus the slope times x. And you leave the x as a variable. Don't put a value in for x. That's a hard thing for people to get over. So here I'm going to say y hat equals the y-intercept, which I didn't write, but I'm going to squeeze this in real quick. So forgive me for just one moment while I squeeze in the y-intercept. Okay, so that came out as we just rounded it to 7.3. Oops, sorry. 7.3. Right, so now I need to do the y-intercept plus the slope times x. So the y-intercept is 7.3 plus the slope, but the slope's negative, so adding a negative is the same as subtracting. So we're going to say minus 0.591, and then again times x here. But x is just a variable, so you just set an x there. Don't put a number in. Just like that. Okay, and I'll put that into the answers here and see if we get it right. Y hat equals 7.3 minus 0.591 times x. You can say times with an asterisk, or you can just say an x down. It kind of gets it if you don't put the times in. So we're good to go there. And now it's time for interpretation. So let me zoom out there. Okay, so the best interpretation for the line slope, and I've got the interpretations here. So just one moment, I'm going to get a different color. All right, so slope interpretation is the change in y hat. Now y hat will be in amps, electric current, in amps. So X is the pH of the electrolyte. So if you increase the pH by 1, the electric current in amperage will go up by whatever the slope is. Okay, so I would say as pH increases by 1, electric current will go up by the slope, which was, it'll actually go down by negative 0.591. Okay, so it'll change by negative 0.591. So let's see if we can get this straight here. When the electric current increases by 1, that's wrong. It's when the pH increases by 1, predicted electric current changes by negative 0.591 amps. That's basically what I said. So I'm happy about that. Next, the y-intercept. So for the y-intercept, we have an interpretation here. It's the value of y hat, the predicted value of y, when x is 0. Now, so this would be the electric current, and when x is 0, that's just the pH. So if the pH is 0, which is a pretty strong acid, if the pH is 0, then this will give an electric current. So let's see if we can find that. This is predicted electric current when the pH is 0 is 7.3 amps, and 7.3 was the y-intercept. No. The y-intercept was 7.3 amps. Okay, so correct. The predicted electric current when the pH at x is 0 is 7.3. The y-intercept will go with that. Okay, and I think I'll check my answers just to make myself feel better about myself. It's always so important for me. I'm a very insecure person. And so we got all this in. I didn't get marked wrong. I thought we got little squares around it. I wonder if I didn't click it right. Part answer. There we go. There, these are correct. And now the line of best, we use the line of best fit to estimate the value of y hat, which is the electric current when the pH x is 2.9. So going back to the iPad notes here, we're going to say x, that x is 2.9, which means that y hat, this would be, the formula for it is 7.3, and I'm just using this up here. So 7.3 minus 0.591 times x, which is 2.9. Okay, so we'll figure out what that is on the calculator over here. So we're doing 7.3 minus 0.591. Oh, dang it. 7.3 minus 0.591. You got to do times with the asterisk there, and x, which is 2.9. Okay. Just double checking. Looks good. So this would be, and they only want one place here. So we're going to call that 5.6. So I'll go ahead and key that in here as a 5.6. Now that would be, this is the electric current, so that'll be amps. Okay, so let me go ahead and do y hat. My predicted current is 5.6 amps for that battery. These are pretty precise. Whenever you do kind of just science, like the hard sciences, not the social sciences, not that those are easy, these are usually pretty great tools for predicting things. And we do that in the physical sciences all the time. So y hat is 5.6. I'm going to check that again. Go back up. Looks good. All right, now the joyful part, which is the graph. And so I have to drag these points up. So this first point A is 2.2, 5.7. And then I watch the coordinates of A right here. That's the first point, until it gets to the right location. So 2.2 and then way up to 5.7. I'm just looking at it. I'm at 2.1. There it is. 2.2, 5.7. Next point should be 6.5, 3.3. So 6.5 over here. Oh, it goes way down. And then 3.3, too high. There we go. Right here, 6.5, 3.3. All right. Next one is 6.8, 2.8. So that's C. 6.8 and way down to 2.8. Let's see if I got it. I got to go up a little. There you go. 6.8, 2.8. It's going downhill. Stronger acids have low pHs, so the strong batteries are on the left, and the weaker batteries on the right. A pH of 7 is a neutral pH, so basically the battery kind of dies at that pH level. Okay, so at D we're supposed to do 2.5, 5.7 up here. 2.5, 5.7. So 2.5 is here. 5.7 is going to be down here somewhere. 2.5, 5.7 right there. Oh, it didn't let go. Dang it. There we go. Got to click it again sometimes. If I do a deep click, I get in trouble. Okay, now E is 3.3, 5.9. So here's 3.3 and 5.9 up here somewhere. Let's see. 3.4, 3.3, 5.9. Good. Now I'm on F, which is 5.8, 4.2. So 5.8 and 4.2 is going to be around here somewhere, just down a little bit, right there. Okay, G is 3.3, 5.6. Up a little, right there. Good. Now, that was G. We're on H, which should be 5.146. Okay, so 5.1 and down. See if I can get this right. 5.146 right there. Then I is 6.336. So let's see here. 6.3 and then 3.6 is going to be in here somewhere. Right there. Last one, 2.4, 5.5. Let's grab it. 2.4, 5.5 is going to be somewhere in here. So I can get this right. Up right there. 2.4, 5.5. Yeah, so that kind of has a downward trend. It looks a little curvy, but we are doing linear correlation here. So I think I could figure out how to put a line through that. And so I'm comfortable saying linear on this one. And it's close enough, I think. And I skipped something. I'm supposed to put the line in here. So the mean point is here somewhere. We'll highlight that again. The intercept we got to put down. It's going to be up here somewhere, obviously, the y-intercept. It needs to be on the y-axis, so make sure that the x-coordinate for I up here is 0. And I think it was 7.3, right? So the y-intercept here was 7.3. So I just need to move this up until I see this 6.9 go up to a 7.3 on the y-intercept, just up a little. Right, right there. Okay, now the mean point here, you want to look at the mean of x, which is 4.4, and the mean of y, which is 4.7. So I just need to drag that point. So the x-coordinate is 4.4, and the y-coordinate is 4.7. So let's see here, 4.4. I think I got to go down, don't I? I'm looking at the coordinates over here. I'm at 4.4, 4.8 there. So I got to come down just one more click. Double check it. 4.4, 4.7. That's what these say for x bar 4.4, y bar 4.7. That's the mean point because it uses the two means. And it should be right in the middle of the x's and y points. And that is a line of best fit right down the middle of the data set there. So it looks great. I'm going to go ahead and check my answer at this point. Everything should be green. Yeah, this will be completely surrounded in green if you did it right. And also, just a kind of quick note here. Yeah, I guess we're good on everything. Yeah, it gives you the line of best fit up here in case you get it wrong. So you can see the y-intercept is 7.3. You definitely need the means for the mean point. So here's your mean point, 4.4 and 4.7. That's that mean point on the line. So basically, if you get these wrong, you'll still have the correct answers here, which allows you to graph this line correctly. Okay, so that's that. And then is the relationship positive or negative? Well, the line definitely goes downhill. As I said, increasing the pH for an acid means that the acid is going toward neutral at 7. So the batteries get weaker as you do that, and that's a negative relationship as the line goes downhill there. It's a negative relationship. Now, is the relationship weak, moderate, or strong? And that depends on the value of R. So I think I'll go over to this and remind you that R, right? Let's see if I can pinch on that. So R is negative 0.954. And down here I have that graphic that we were looking at in class. And negative 954 is going to be right in here somewhere between negative 0.8 and negative 1. So it's a strong relationship and negative. But yeah, we'll definitely classify this one as strong. Okay. And now it's going to ask for the value of R squared, which I don't know if I made a space for that. So I'll do it down here on my iPad. So, and let's see if I do it in green. You can see that better. R squared is, we'll just get that R value, which is negative 0.954. And we're going to square that. And just a quick reminder, if you don't use parentheses on the calculator, then you shouldn't put a minus sign in, because calculators want parentheses with negatives if you're going to square them. It's a long story, but you know, you need to square the negative, not just the 0.954. 0.954. So it needs to be grouped like that and then squared. So I'll click on this square button there. And then, what'd I do? Oh, I used the subtract button when I should use the negative button there. So don't make that mistake. And so there you go, 0.910. You get the same thing. You see those minus signs, such a hassle. So you get the same thing as if you just do 0.954 and then square that, because squaring a number is going to make it positive either way. And so it's easier just to ignore the minus sign when you square a number. Okay, so 0.910 either way, 0.910, which is going to treat that as 91%. And then we're almost done here. And just kind of remind you how you interpret R squared. So R squared is the proportion of variation in Y that's explained by X. So Y is the current in amps, the electric current. And X is the pH of the acid. And so we're just saying as the pH increases, so that we saw the amperage go down, and so we've got all this variation in amperage. And since R squared, I didn't put it down, it was 0.910. So since R squared is 0.910, we would think of that as 91%, okay, of the variation, of that variation in Y is explained, in the electric current, okay, is explained by the pH of the electrolyte. Let me say it again. 91% of the variation in the electric current, which change depending on the acid, 91% of that change is explained by the pH of the electrolyte. So I'm looking for that conclusion. This is wrong. The electric current can be explained. No. 91% of variation in electric current can be explained by electrolyte pH using line of best fit. That's absolutely perfect. And we're good to go. All right, so Good luck on this homework. And just want to remind you, there you'll get. I think there's a few problems. I haven't done it in a while. I think there's a few problems where these points come out really curvy, and so when that happens, you kind of want to just say it's nonlinear. And in those cases, the problem will not have you find the line of best fit if it's not kind of something you could approximate with a line. Okay, so I'm gonna go ahead and end this one, and good luck to you guys.